What's the sum of k squared from 1 to n? So that is 1 squared plus 2 squared plus 3 squared up to n squared. So let's first start by calling this something. We'll call it Sn. And now let me offer you another way to look at this. I'm going to make a little triangle like this. And the top will have 1, then we'll have 2 2s, 3 3s, and so on up till n. And of course that'll be n n's. What is the sum of all the values in this triangle? That'll be 1 plus 2 plus 2 plus 3 plus 3 plus 3, and so on. And that's going to be 1 plus 2 times 2 plus 3 times 3. So in other words, the sum of all these values is going to be the exact sum that we're looking for. 1 squared plus 2 squared plus 3 squared, and so on. So now that we have that, let's see if we can sum all these in a slightly different way. Let's go along this diagonal right here. So I'll write this as 1 plus 2 plus 3 up until n, plus 2 plus 3 plus 4 plus whatever up until n, and so on, starting at a different location and ending at n. So we'll just be left with n. So maybe we can write this in a summation formula. This is basically just the sum of some index k starting from 1 to n. Okay, this is the same thing, but we start at 2 instead of 1. So k equals 2. And so on. Up until n. Well, we can just rewrite that as the sum of k from n to n. And let me just write this in blue right here, this starting point. 1, 2, here we'll have 3, 4, 5, up until n. We have the sum of some values, the starting point, which is changing. So we can actually just rewrite that itself as another summation. In other words, a double sum. So this starting point, let's call it S. So we'll have S equals something, starts at something and ends at something else. And we're going from k is S until n. So we start at 1, and then we do another 1, 2, 3. So we're going to be starting at 1 and ending at n. So this is actually just another way to rewrite the sum, 1 squared plus 2 squared plus 3 squared up until n squared. Now let's figure out what this is right here. So here we have the sum of k starting from s and going to n. So if we write that out, it's going to be something like s plus 1 plus s plus 2 up until n. And of course, let's add 0 to this. Let's start by doing 1 plus 2 plus 3 up until s minus 1, and then we'll just subtract that. And then we'll add the rest. So this top right here, this is just the summation of 1 until n. And this is subtracting the summation of 1 to s minus 1. So we can write this as the sum k equals 1 to n of k minus the sum k equals 1 to s minus 1 of k. Okay, and now, wait a minute. We know formulas for this. This is just, if you saw in the last video, this is just n times n plus 1 over 2. And this one, we'll add a subtraction for that. This is going to be the same thing, but we replace n with s minus 1. So here we'll just have s minus 1 times s over 2. And now let me just rewrite this really quickly. This is just the same as 1/2 times n times n plus 1. And then we have minus s squared plus s. Okay. Now let's rewrite our sum. We have s of n is equal to the sum starting from s equals 1 to n. And now I'm just going to add in this blurb right here. 1/2 n plus 1 plus s minus s squared. And now I'll multiply both sides by 2 and distribute this sum. So that tells us that 2Sn is equal to sum s equals 1 to n of n plus 1. Then we have plus the sum of s equals 1 to n, minus the sum of s squared from s equals 1 to n. And what is this? Well, this is just exactly what we're looking for. This is just Sn. This right here is the same summation from earlier, and this sum right here doesn't depend on s at all. So let me just add this Sn to the other side. This tells us that 3Sn is equal to, okay, well, we can take this, since it doesn't depend on s at all, we can just take this expression and move it outside, and we have the sum of 1 n times. So we have 1 plus 1 plus 1 n times. Well, that's just n, right? So we have n times n plus 1 plus the sum of s. Well, what is the sum of s? That's just n times n plus 1 over 2. Okay. Now let's combine this into one fraction. Here we'll have 2. We'll multiply this by 2 and divide it by 2. So we'll get 2n times n plus 1 over 2 plus n plus 1. So we can now rewrite this. We'll factor out this n times n plus 1. That's equal to 2n plus 1 times n plus 1 over 2. And now, dividing both sides by 3, we'll get Sn, which is just the sum of k equals 1, k squared to n. This is equal to n times n plus 1 times 2n plus 1 over 6.